Hey everyone, welcome back to Embedded Ninja. Today we are going to dive into a topic that a lot of people get confused about, that is C versus embedded C. If you have ever wondered what the difference is between these two programming languages or where they are used, stick around, we are going to break it down this concept for you guys. So before we learn about the difference between C versus embedded C, we really need to know the application layer and hardware, like where the application layer is present, where the hardware is present, where what are the in between layers. So let's dive into it. The first layer is application layer, and application layer is also called as user space. The application layer is a part of a program where you write actual instructions for what you want to code for. For example, you can even code an hello world program in your IDE, or you can even build a simple calculator program in your IDE. This particular layer does not care about how your hardware works. It only focus on the whatever code you write, it will be showing the output in the graphical user interface or in the terminal. This is all about the application layer. The next layer is operating system layer. Operating system is present in between the application layer and the hardware layer. Operating system actually takes care of all the difficult things for you. For example, you're going to write a program in C to save a particular text in the memory, but you're not directly going and tweaking the hardware. You are just using the file handling C header file. These header file as a APIs of the operating system, and then it will directly go and store it in the hardware. So operating system abstracts the difficult part for you. So it will be writing efficient code in the application layer. In the application layer, we don't use embedded C because normally embedded C is directly, we will be using directly in the hardware. But in the application layer, we mostly use normal C language. So the next layer which we are going to see is HAL. HAL stands for Hardware Abstract Layer. It contains APIs related to CPU peripherals. Consider a scenario where we want to store a particular value inside the register, but we don't know at what base address this particular register is present. This is where HAL help us. HAL contain function. What we can do is we can directly use this particular function and store it. Or else what we need to do is we need to go and fetch the base address from the datasheet, because datasheet contains all the references related to a particular CPU. So we need to go and refer the datasheet, and then we have to define it in the header file, and then we have to use bitwise operators to store the value inside the particular register. These are some tedious tasks. So this is where hardware abstract layer helps us. Hardware abstract layer, as I mentioned earlier, it just has a built-in functions, built-in function related to the particular CPU. So we can use this particular function to directly talk with the hardware. This is the role of hardware abstract layer. So we'll go to the next. So the next layer is hardware. Hardware is where actual physical component is present. So on top of hardware, we have HAL, hardware abstract layer. And on top of HAL, we have operating system. And on top of operating system, we have application layer. So when I say embedded C, embedded mentions the environment. So whenever we write a C program on the HAL or directly on the hardware, this particular thing states as C called as embedded C program. We can also directly write code on the hardware platform. Writing code directly onto the hardware is also called as bare metal style of programming. This helps us to directly tweak the registers of the hardware. Let's summarize whatever you will learn. If you write a code which is dependent on operating system, and it will be mostly on top of the application layer, it is called as normal C. Embedded C is actually it will not depend on operating system. It is actually writing on the hardware or using hardware abstract layer. Hardware abstract layer contains the functions so that we don't need to worry about the pin numbers. So in or else we can also directly write on the hardware platform. In these scenarios, we will be calling this as embedded C. In this particular example, I'm going to demonstrate how normal C program syntax will look like. First, we need to write header file hash include stdio.h, because I'm just going to print a basic hello world. For that, we need an entry point. For the entry point, we are using main function. printf hello embedded ninja, and I'm going to return 0 because it is not going to return anything. And if I run gcc demo.c, if you don't feel overwhelmed, because we'll be seeing this in the upcoming lessons. Look here, it is printing hello embedded ninja. This is how a normal C program syntax will look like, but in embedded C it will be a bit different. We will see that again. So this is how an embedded C code looks like. So don't get overwhelmed. We'll be seeing this in upcoming video lectures. So the reason I'm showing this code is because I'm actually telling that embedded C is a specialized version of C. It is mainly designed in order to run directly in the hardware. Because in this particular example, I'm just showing you to blink a basic LED. And also I mentioned embedded is a resource intensive. So we need to be very careful that whenever we declare a particular data type, we should not be declaring it like how we used to declare in the normal C. In normal C, we'll be declaring int a equal to 0. But if you look carefully, integer is a very big range. Like 32,000 from minus 32 to plus 32,000. So but in embedded we have a constrained environment, so we need to be very specific, like mentioning it as u int 8. U means unsigned integer of 8, size 8-bit. So by making it as very specific, we can, it tells that the resources are very limited, so we have to be very careful while writing the code. This is the syntax for this is how the syntax look like in embedded C. So we'll be looking at very detailed in the upcoming video lectures. So don't get overwhelmed. I'm just showing you the example for how an embedded C code looks like. If you understood the difference between C versus embedded C, hit like and subscribe. Thanks for watching. I will see you in the next video.